Hello students, in this course wireless networks we will discuss about the various salient features of different types of wireless networks. So in the previous session we have initiated the discussion on IEEE standard. So we were talking about 802.11 and its different categories. So we further discussed about the IEEE 802.11 protocol stack, the various layers under the protocol stack, physical layer is the bottommost layer, MAC layer, the middlemost layer, and then the upper layers. So in this topic, we'll look after the MAC layer. So today's discussion will start with the course outcome of Unit 1 to write the salient features of various wireless networks. IEEE 802.11 MAC sublayer protocol. So whenever we talk about the MAC layer, we encounter the two most common problem. The first one is the hidden terminal problem, and the second additional problem is the exposed station problem. So to encounter these two problems, our standard supports two different modes of operation. So the first of its kind is DCF, distributed coordination function, and the second one is PCF, which is point coordination function. So first let us briefly address the first problem, which is about the hidden terminal problem. So this is the block diagram. This illustrates a scenario where we have three different nodes A, B, C, which are in a wireless local area network, and all the three needs to communicate between each other. So whenever we talk about this hidden terminal problem, here the wireless stations have transmission ranges and not all the stations are within the radio range of each other. So our traditional CSMA technique will not be deployed here. So this cannot hold good in case of such scenarios. So in the previous slide, we saw three different nodes A, B, C. Now let us assume that C is transmitting to node B wirelessly. And if the node A senses the channel and it is not able to hear C's transmission, what will happen? So when C needs to transmit to B, and if suppose it is not hearing C's transmission, A will falsely assume that there is no transmission to B from C, so that it can transmit its data from A to B. So this kind of problem where A falsely concludes and begins its transmission to B is known as hidden terminal problem. So here C is the terminal which is hidden from A's range. And the next issue is the exposed station problem. So this is the vice versa problem. So here the same scenario where we have three different nodes A, B, C, and in case B wants to send data to C and it starts listening to the channel. When B hears A's transmission, B falsely assumes that it cannot send to C. So such an issue is known as exposed station problem. So in order to address these two, there are two different technologies which are IEEE 802.11 standard supports, and the first is distributed coordination function. So this method deploys CSMA along with collision avoidance. So carrier sends multiple access with collision avoidance. So I hope we might have learned this concept already in communication networks paper. So in that course, the concept of carrier sends multiple access along with collision avoidance and collision detection might have been discussed detailed. So this CSMA CA tries to make use of any one of the mode of operation. Either it can be a virtual carrier sensing or a physical carrier sensing process. The first one, or the methods that are supported by the CSMA collision avoidance technique, comes under multiple access with collision avoidance for wireless, which in short is referred to as MACAW, multiple access with collision avoidance for wireless networks. And this comes under the first mode of operation, which is known as virtual carrier sensing. And the next operation, or the mode of operation, is about physical carrier sensing. So this MACA protocol tries to address the hidden as well as the exposed terminal problems. The sender broadcasts a request message called RTS, which is request to send, and the intended receiver sends back CTS message, which is clear to send. Upon the receipt of this message CTS, the sender begins transmission of the frame. So both RTS as well as CTS is in fact helping us to determine who else is in the range, or who else is there in the range of network, and it helps us to prevent collision in the network. Apart from this, the MACAW also adds acknowledgement receipts, carrier sense, as well as BEP per stream and not per station. So all these bit error mechanism along with acknowledgement receipts still supports us to avoid those two problems, which are hidden terminal problem and carrier sense, or exposed carrier, exposed station problem. So this diagram illustrates the use of virtual channel sensing using carrier sense multiple access collision avoidance scheme. So here we'll be able to observe the data frames RTS request to send and CTS clear to send along with the acknowledgement packet. Yes. So what is the advantage of making use of this RTS and CTS? RTS is actually of 20 bytes, whereas CTS is of only 14 bytes. So by the word virtual channel, it actually implies that the source station sets up the duration field in the data frame or in RTS and CTS frames. So apart from sending RTS, CTS messages and acknowledgement packets, we also include the concept of stop and wait protocol on all the fragments. So this greatly helps us to avoid collision. So this is the second mode of operation, which is known as persistent physical carrier sensing. So far we might have discussed about virtual carrier sensing, and now we are moving on to physical carrier sensing. So here the station senses the channel when it wants to send. If the channel is idle, the station can start to transmit. A station will not sense the channel whenever there is transmission in process. So if in case the channel is busy, the station will defer and until it is idle. So once the channel becomes free, we can start to transmit. So this is known as one persistent. And when there is a collision, the channel, whenever there is a collision in the channel, the nodes waits for a random time using binary exponential backoff. So after that duration, it again goes for retransmission. So the next methodology is known as point coordination function. So this PCF, point coordinated function, makes use of a base station to poll other stations to see if they have frames to send. So in this scenario, there are no chances for collision, or there is minimal chances for collision to occur. The base station sends the beacon frame at regular intervals. Also, the base station helps us to tell another station to sleep mode to save on batteries, and the base stations also holds the frames for sleeping station. So this PCF method ensures minimal collision and power consumption is much reduced compared to the previous function. So with this, we'll end this session, and in the next session, we'll move on to the other IEEE standards. Thank you.